And the last speed is VA, which is called the speed of advance. Theoretical speed, we know the formula already, I have told you, pitch into RPM into 60 divided by 1852 knots. The shift speed, you are an expert, you will get from the GPS. Now let us see what is this speed of advance. Let us say this is a ship. This is the propeller. Now when the ship moves forward, there is a layer of water which moves along with it slowly, not at the same speed of the ship. That's because of the viscous drag of the water. And this is the water body around the propeller, which also moves slowly along with the vessel, not at the speed of the ship, at a much lower speed. Fine. So this is called the wake speed. This is the wake, and the speed at which the wake moves forward is called the wake speed. And the speed of advance is the speed of the ship in relation to this wake. The ship speed V is the absolute speed of the ship as per GPS, and the speed of advance is the speed of the ship in relation to this wake, which is moving slowly along with the ship. Ship speed is the speed of the ship in relation to the ground. Speed of advance is the speed of the ship in relation to the wake, which is not stationary like the surrounding water. It is moving slowly along with the ship because of the viscous drag. So with these three speeds, theoretical speed Vt, ship speed V, and speed of advance, we shall go through some simple formula now. So apparent slip is the theoretical speed minus ship speed divided by the theoretical speed, and since it is a percentage, we have to multiply it by 100. Normally, apparent slip is the one which we calculate on board. Next, we come to real slip, which is absolutely for the designers. We don't need it on board. So, real slip is theoretical speed minus speed of advance divided by the theoretical speed. And since it is percentage, we have to multiply it by 100. And the last one which we have is a wake fraction. This is not a percentage, it is just a fraction, which is denoted by ship speed minus speed of advance divided by the ship speed. So here there is no 100 to be multiplied with because it's not a percentage, it's a wake fraction only. So these are the three different types of slips or that indicates how imperfect the propeller movement is because it is running in water. And this wake fraction is also denoted by a small formula 0.5 Cb minus 0.05, the Cb being block coefficient of a vessel. Let us see some more formula. Yes, there are quite some more formula. Pitch ratio. Pitch ratio is pitch of the propeller divided by the diameter of the propeller. So we know the pitch of the propeller. We have already seen how to calculate that. Pitch we already know, and diameter is basically if we take a propeller like this and the propeller tip draws a circle, so naturally the diameter would be this. So pitch of the propeller divided by the diameter of the propeller is termed as the pitch ratio. Next we come to blade area ratio, which is actually the developed area minus boss area divided by the area of the circle cut out by the propeller. Let me describe or explain what's a developed area. Let me draw a propeller again. Let us say this is a propeller along with its blades. So I am just shading the blade areas. I have just shaded out the blade area, and the red one is the area of the boss. This developed area includes the blade area plus the boss area. That is the total projected area of the propeller with the blade and the boss. So from the developed area, we subtract the boss area, which is the shaded area in red, and divided by the area of the circle cut out by the blade tips. What is the area of the circle cut out by the blade tips? If the propeller moves, this blue part, blue circle is the area cut out by the blade tips. That is the denominator out here. So the numerator is the developed area, area of the blade plus the boss, that's called the developed area, minus the boss area. Basically, this numerator, what it means, it actually means it is only the blade area. You might as well write this as blade area divided by area of the circle cut out by the blade tips. So that is called the blade area ratio. Next we come to disk area ratio. This is developed area divided by the area of the circle cut out by the blade tips. Developed area, as I have just told you, includes the blade area plus the boss area. Blade area plus the boss area. All the complete area is called the developed area. And developed area minus the boss area, I have just told you, that actually is only the blade area. Area of the blades only. So here we are taking the total area, blade plus the boss, and divided by the area of the circle cut out by the blade tips, which is called the disk area ratio. Yes, there are a couple of more formulae that are left. Delivered power in watts is equal to torque in newtons into 2 into pi into revolutions per second. Please note this, not revolutions per minute, but revolutions per second. That's the torque developed by the propeller, and finally we get the delivered power. Yes, previously in the power chapter when I taught you to calculate a ship's power, we did come across delivered power. That was a slightly different formula, let me tell you. So I will just write it down for you. There we saw that the propeller efficiency is equal to thrust power by delivered power. Please refer to my previous video named Ship's Power Calculation, where we came across this efficiency, where also we had the delivered power. But here the delivered power has a slightly different formula which uses the torque. We are calculating the delivered power from the torque generated by the propeller. And we have thrust power. Yes, I just wrote down thrust power also we had in the propeller efficiency. Thrust power by delivered power. This was the previous formula. Here we are calculating the thrust power by the thrust generated by the propeller. So thrust power is thrust into speed of advance in meters per second, not in knots. You have to convert the speed of advance into meters per second. How will you convert? If speed of advance, this is the knots, you have to multiply it by 1852 and divided by 60, converting into minutes, another 60, converting it into seconds. So this is the conversion factor for converting speed of advance in knots into speed of advance in meters per second. So the same formula, the same numerical we come back, where we had to calculate the pitch. Yeah, there are two other parts. Then we have to calculate the apparent slip and a real slip. The pitch part we have already calculated, so I will just walk over it, and then let us calculate the apparent slip, for which we need the theoretical speed. Because if you remember that apparent slip is equal to theoretical speed minus ship speed divided by theoretical speed into 100. And the ship speed is given. So we need to calculate the theoretical speed. So let us calculate the theoretical speed, which is the pitch of the propeller into RPM into 60 divided by 1852. We get the theoretical speed as 17.45 knots. From here, we can calculate the apparent slip, because apparent slip is theoretical speed minus ship speed divided by theoretical speed into 100. This gives us the apparent slip. And then we have to calculate the real slip. You see, the wake fraction is given. From that, we can calculate the speed of advance, because for real slip, we need the speed of advance. So this is the formula for wake fraction. Ship speed is given, wake fraction is given. We can easily get to know the speed of advance. So this is the calculation for speed of advance, that is 10.85 knots. If you want to go through the calculations again, you can just pause your video at this point and then check up the calculations, how it has been done. So we get the speed of advance at 10.85 knots. And real slip, we know, is the theoretical speed minus speed of advance divided by theoretical speed into 100. And we get the real slip as 37.96%. So we have got the apparent slip and we have got the real slip, and the pitch already we had calculated. This is the apparent slip and this is the real slip. So that's how we calculate a propeller numerical with the help of those around 10 or 11 formulae that I have told you. It's very simple. You have to just apply the formulae directly and then you can go ahead with it. Okay, we have actually just finished off with the propeller chapter. Please look out for my next video on more numericals on propeller and resistance of a ship. Thank you, and till we meet again.